function is actually a rather important one, as you might guess from the name. 5.3 is about the fundamental theorem of calculus. And there are actually two parts to it. And I'm not going to give you either one in this video, but that's okay. What I'm going to do is create a function that's a really, really important function that it's necessary to understand in order to get one of the parts of this fundamental theorem. Okay. So I'm going to suppose that this right here is a t-axis, and I'm going to have some function f of t. Let's go with f of t equals t plus 1. Okay, so that's just going to be, actually I'm going to make it 1/2 t plus 1, just so it'll fit a little bit better. That's a line of slope 1/2 and y-intercept 1. So I've got that function there, okay? And then I'm going to choose a particular value of t. I think I'm going to choose 2, and I'm going to view that as my starting point. Okay. So I'm thinking of this as a height function, and so when I'm talking about height, this is going to be my t-axis. But now I'm going to overlap an x-axis on this, because I'm going to define an area function. And area is going to be a function of x. So height is a function of t, but area is a function of x, but the x-axis is overlapping with the t-axis. So when I'm here and talking about height, t is 2. When I'm here and talking about area, x is 2. Okay. And I'm going to define the area at x to be the definite integral from 2 to x of f of t dt. Okay. So I've got 2 is going to be my lower limit of integration. X is my upper limit of integration, and that's the variable. That's what area is going to depend on. Okay. So height is a function of t, but I'm sort of imagining that this entire height function is just fixed. It's just sitting here. Okay. And what I'm going to vary is how far away from 2 I go. And I want to get the signed area between that curve and the x-axis, because when I'm talking area, it will be the x-axis. Okay. So one thing that's really important to note is that this variable cannot be the same as this variable. Because if my x is over here, then what I'm doing is I'm finding this area between 2 and x. X is busy being the right endpoint. T is going to take on all values in between 2 and x. So you can't be at the endpoint and simultaneously be taking on all values between the starting point and endpoint. So these have to be different variables, okay? And if I wanted to evaluate this then, let's just take a look. Let's get some practice with this. Let's say I wanted to evaluate a of 4. Okay. Well, in that case, x would be 4. So I'd be taking a look at an area of a trapezoid that looked like this. The base would be 2. The height over here would be 1/2 of 2 plus 1 would be 2. Here it would be 1/2 of 4 is 2 plus 1 is 3. And so I would say this is going to be, the base times the average height. So 2 plus 3 over 2. So this area here would be 5. Okay, so, but that area depends on the fact that I stopped at 4. If I wanted to find the area at 6, I would be going further. So I'd come over here to 6. Now we're looking at all of this area. So now my base is 4. This height is still 2. This height is 1/2 of 6 is 3 plus 1 is 4. And so I would have my base times my average height which is going to give me, let's see, that's 10 divided by 2 is 5 times 4 is 20. So a different upper limit of integration gives me a different area. Now, if you remember, in the last section, we defined some things that seemed a little bit strange. We defined things like the integral from 2 to 2. Well, that's important because that puts 2 in the domain of this area function. The area at 2 would be the integral from 2 to 2 of f of t dt. Now, that's essentially not going anywhere. So we're getting this degenerate rectangle that has a base of 0. And we said it makes sense to have that be 0. We weren't convinced that it made sense to define that at all. Why would we bother? But that's important because now I can say that whatever the domain of my height function is, and for this height function the domain is all real numbers, now it's the same domain for the area function. So I don't have to create a new domain that's different when I'm working with the area function. And that's because we also defined what would happen if my upper limit of integration was smaller than my lower limit of integration. So let's say I wanted to find a of -1. Okay. So -1 would be over here. Now, we'd still be at a positive height because we'd have -1 1/2 plus 1. So we'd still have a positive height of 1/2 over here. So I'd be looking at finding this area right here. Now I'm integrating from 2 to 1. So we're going backwards. We said what that does is that counts the base as negative. So we're going to count the base as -3. We're going to get the opposite of the area that we get if we came in the positive direction. Okay? And we can accomplish that by just making the base negative. This height we said was 1/2. This height we said was 2. So I'm going to get -3 times the average height, which would be 1/2 plus 2 all over 2. So let's see, that's -3 plus 5/4. Notice this would be 5/2 divided by 2 is times 1/2, so that's 5/4. Oops, it's not plus, that's times. So this would be -15/4. So by having it so that this upper limit of integration can be the same as, or smaller than, or bigger than this number here, we get that the domain for this area function matches the domain for the height function. Okay, so as a general rule, our area function is going to be the definite integral from, we'll have some fixed starting point as our lower limit of integration. X, our variable, goes there. It's the upper limit of integration. Okay. And then we've got some height function, f of t dt. Okay. And we're basically imagining that the height function is just hanging out there, it's sitting there, and all that we're doing then is changing what this upper limit of integration is, which is going to be one of the endpoints of my interval. So I'm going to just give you a different height function here. Let's suppose that my height function is this function that goes through the origin. These tick marks are 1 apart. Okay. And so it comes up like so, and then across at a constant height of 1. I'm going to have it continue down like so. Let's say this is -2, and this would also be -2, and then it's going to continue this way. So this is my height function here. It starts out at -2, and then at time -2, it starts going up with a slope of 1 until we hit 1, and then it stays constant at 1. let's choose 1 as our starting point. Okay. So I'm going to define a of x. In this case, this is sort of the generic version. A of x is going to be the integral from 1 to x of f of t dt. So I've given you a specific height function, and I've given you a specific lower limit of integration. I'm going to give you 3 problems to evaluate with this now. I want you to evaluate a of 3, a of 1, and a of negative 3. Okay. So I'm going to end this video here, but giving you this assignment. The next video will start, and we'll go through these 3 problems together.